Okay, everybody. I just want to show how to create simple health systems using Blender and the tissue add-on. I don't want to use the default cube, but I can create a plane. And in this case, the best option is, in this case, use just a portion of the default plane, that is the one that goes from the origin of the object to the point with coordinate 1, 1. So I subdivide that plane, and sorry, this is the point that I want to keep. I can delete those faces. Okay, why I want to do that? Because if I do a tessellation, like create the default cube, and I want to make I'm just doing something randomly, something like this. So I want to copy some geometries without taking care about the borders, that everything would be automatically adapted to the size of the component that I'm creating. I can use that technique and do a tessellation. Sorry, create tissue, tessellate, and here in component XY I can use constant, and this will use the coordinate that increase the offset. Okay, so this will use the coordinate of this small plane, not because I have drawn that, but because it's just considering the coordinate of that space in order to map each of those faces on my base object. Otherwise, if I use adapt, tessellate, adaptive, okay, everything is automatically fitted into the sides of that. Maybe it's more clear if instead of a cube I use another plane. So this is my default plane. I do tessellate, can scale it, change its size. If I do tessellate, adaptive, I get this. So it's automatically adapt to the size of this face. So you see that there is no matching between this small plane here and the plane that I'm using. But if I use tessellate constant, okay, now as you can see they match perfectly, and I kind of want this feature for doing what I'm going to do now. So let's delete that one, and now I want to create a copy of that and merge it at center, because I just want to start to create the branch starting from this middle face. Using tessellate, we are able to create copies of one component according to the faces of a base object. So that means that in order to tell to the software where to create new branches, you have to use faces in the position of the starting point of each branch. So you can kind of extrude in that way, and in that way. Okay. So now I have to define which are the starting point for the next branches. So I need to create planes also here and here. So I can select this. Now I can set my 3D cursor here and move this one here. I can scale it down a little bit. I can rotate as I want, and the same thing with that one. So before I have to move the 3D cursor to selected here, selection to cursor offset, otherwise everything will collapse in the center. Now I can scale it a little bit down and rotate in that way. Okay, so this will be my component and also my base object. So now what I want to create is a copy of that object, because I have to use that as both, but I prefer to create a linked copy. So you can use Alt D and create this copy here. Okay, and now I can try to do tessellation. I select both and I do tessellate, and component XY is turned on. Okay, fine. I can use merge, but yeah, I will explain that later. And now, okay, good, it works. Sometimes can happen that because of the rotation of the faces, like for example RZ9, 90, if the rotation is not aligned, when you do tessellation, you can get this. So you see that it creates the branch in a rotated way. So in that case, I don't have the matching between the end of those branches and the beginning of those. So at the beginning, you probably have to check which is the rotation of the face, and if it doesn't work, you just need to rotate of 90 degrees or 180 degrees. Okay, it works. So now what I want to do is to repeat that operation with several iterations. So we can change the settings, and we can also, okay, it's important that you keep, okay, let's do this. It's important that you keep the offset to 1, otherwise by default it will be 0 and everything will be moved. But you want to create the component putting the component starting from the middle of the face. So offset should be 1, as you can see. You can also use a proportional scale according to the sides of those faces. And as you can see, according to how big are those faces, the branches will be smaller or bigger. Or you can, okay, in this case we will lose the alignment. Or you can just use a constant scale, but also in that case doesn't work. Okay, no, so it's better to keep it 1. So you can choose if you want constant or proportional. And in that case, if you want to change them, you need to scale those faces, and this will affect the sides of a branch. Let's give a look to what happened. For example, if I scale that face here, make it smaller. If I refresh that, you see that some of them are now smaller. Okay, so now if I want to make several iterations in order to create my branching system, I can change the settings of this one. This object is called cube tessellation, and I can use as base object the object itself. And if now I press OK, you see that it creates another little branch. If I refresh many times, you see that it creates all the next iteration. Okay. So let's see a different one without changing the scale according to the size of those, or just maybe keeping them a little bit bigger, like this. Okay, so we can do tessellate. Now make it proportional, constant. This is 1. Merge, but it doesn't work on the edge because of a small bug of this version of tissue. And okay, so again, I can change the settings. I can use the cube tessellation. This is the new one. Okay, good. And now refresh. Many times. And here you can see this guy here. And the rotation, the scaling effect that you get depends on just this component. Probably in the next version of Tissue I will add an iteration option that automatically generates all the next iteration of this. So let me more of them. Okay, maybe too much. And now I have to clean this model a little bit, so I can go to edit mode, and I can delete all the selected faces. I don't need them anymore. I need just the branch. Okay, perfect. Now I need to remove the doubles because the merge option doesn't work on edge. So W, remove doubles, good. And now we can add a subdivision surface and see this one a little bit smooth. Did it? Yeah, okay. And you can also choose if you want to smooth that or no. Okay, maybe no. Something wrong happened here. Maybe it doesn't merge all of them. So remove doubles. Let's increase a little bit the threshold. Okay. Okay, now it's solved the problem. Okay. Now what you can do now is to use the skin modifier that now can be big complex because it's have very high number of vertices, or you can because I'm using the branch fracture modifier, I can use this remesh option that works with metables, and I can create many metables, one for each vertex. And if I set vertices, it will take a bit because we have many vertices here, and the metables are quite big, but I can change the size to 0.1. Maybe I can change the size more, 0.06, and the resolution should be improved. So 0.1 the resolution, and you see that something is coming, and 0.05. Okay, now we need to clean to make this a bit better. So in order to prevent this effect, I have to increase the number of subdivision, but just because I want to increase the quality in this point, maybe it's better to just select the first branch and subdivide them. Otherwise it will increase the complexity of the whole system. Okay, now if I want to make those connections less sharp and more smooth, I can change the threshold and make it bigger, and also have to increase the size in that case, 0.09. Let's see. Okay, it kind of works. I'm missing some branches here, so I can subdivide also those. Let's subdivide more those guys. Okay. Good. Excellent. Okay, this can be a bit better. Okay. So enjoy.